In this video, I'm going to be showing you how we can prove that the area formula from my last video works. So, we already have this one, but I am going to briefly show you where this formula comes from anyway, which hopefully will not be new to you. The area of a triangle is base times perpendicular height divided by 2. And we've now got this new formula, half AB sine C. So let's have a look at this triangle. And as I said, I want to first just show you where the base times perpendicular height over 2 formula comes from. So the perpendicular height of this triangle, if I say that this B is the base, the perpendicular height of this triangle is just the height going from the base up to the top and making a right angle. That's what perpendicular means. It means make a right angle. So this is our perpendicular height, this line here. Now I don't actually know what this perpendicular height is of this triangle. It can be fairly difficult to work it out. So I'm just going to call this X. I'm just going to call it X. Now this whole triangle is actually just the inside of a rectangle. So you can see how it fits nicely inside this rectangle. Now this rectangle I've made here has a base of B. It has a height of X. So the area of the rectangle, which is just base times height, we know rectangles, they're easy, is Bx, base times height. Now the triangle is exactly half of this rectangle. Can you see how in the smaller rectangle, we've definitely filled in half the space because we've gone diagonal to diagonal. Technically we've bisected the rectangle, we've cut it in half. Or you can see that this triangle is the same as that triangle. There's lots of ways to see the same idea, that we've got half a rectangle, and the same is true of this big rectangle here. We've got half of it, which means that overall we have half of the big rectangle, the really big rectangle, I should say. Which means the area of the triangle is half of the base times the perpendicular height. Half bx, half of base times perpendicular height. Okay, now that's going to be our little bit of inspiration. We're going to use that formula to find our new formula. So I'm still going to need this perpendicular height. In fact, I'm not going to need much else. I'm going to restrict my attention entirely to just this right angled triangle. So I'm going to ignore this half of the triangle entirely. I'm just going to look at this right angled triangle. Now the reason I'm doing that is twofold. Firstly, everything I know about trigonometry comes from right angled triangles. So if I can only look at a right angled triangle, that's going to help me out quite a bit. So it's nice to only be looking at a right angled triangle. And then you might ask, well, why this one? Well, this one has the angle C in it. And I know that my formula asks for sine C. So that's why I want to look at this right angled triangle. Because I am eventually going to have to do something with sine and C. Well, what is sine? We know we have our first formula for sine. We have SO. Sine of theta is the opposite over the hypotenuse, SO. So if I know that this is true, then I can plug in what I've got. So I have that sine of theta, which in this case is C, is the opposite, which in this case is X, over the hypotenuse, which in this case is A. So sine of C is X over A. In fact, I'm going to rearrange this so that I've times both sides by A to get that X is equal to A sine C. Now the main reason I've done that is because I don't want to have an X. I'm going to get rid of this X as soon as I possibly can. The second reason I've done this is that, this already looks a little bit like the formula I'm after. If I can find a way to force half B into this mix, then that is going to be the formula. So let's hope I manage that. Okay, now from the last slide, you know that the area of the triangle is half of B times X. We've got half B, and we've got A sine C. That's all looking promising. So in fact, what I'm going to do is I'm just going to replace the X there, the X in this area of a triangle formula. I'm going to replace it with A sine C, because I know that they're the same. X is A sine C, so I can just replace it. We get half of BA sine C. Almost perfect. Just to finish off, I am going to swap those two letters around because it's multiplication. I can do it in any order. So half AB sine C. And that is how we get this area of a triangle formula. Now notice that because the x isn't in my final answer, I don't now need to think about it at all. I can ignore that x entirely, and I can just use the values that I know, a, b, and c. Okay, so the key points in this video. We already had one way to find the area of a triangle, using the base and the perpendicular height. But of course, perpendicular height can be hard to find. It's nice to get around it. To prove the new area formula for all triangles, we needed to cut the triangle into two right-angled triangles. This trick is going to end up being useful quite a bit in the next few videos, so look out for that. And then finally, we use SOH with one of the new triangles and the original area formula to prove the statement.